Okay, we are now recording. All right, thank you all for joining this edition of our BDPA Tech and Career Talk. I am Devin Jenkins. I'm a Senior Technical Product Manager with GE Healthcare in Milwaukee, Wisconsin. Glad to have you here. I lead our BDPA Tech and Career Talks. So this is our second one of the year. We are glad to have Ryan with us from Blue Granite. As just before we get started, just to let you know, I encourage you to use the chat throughout the call if you want to share thoughts or engage, if you have questions, and then we will make sure we address any questions at the end. I do have all the lines muted right now so we don't disrupt the speaker as we go throughout, but I will allow you all to unmute and ask any questions or share any comments you have at the end. We will allot a good bit of time for that. So thank you for that. For those who may be unfamiliar with BDPA, this is Black Data Processing Associates. BDPA was started in 1975 by Earl Pace and another gentleman whose name escapes me right now. But the whole premise was having a forum or an organization where young people can develop computer technology skills and a forum for IT professionals to network and continue to develop in their careers with the whole premise of going from the classroom to the boardroom. So that's BDPA. I've been around over 45 years at this point and planning to keep things going. And we're glad to have Ryan with us today for this week's edition of our Tech Talk. Just before we have Ryan come on, I will do a quick intro of Ryan. So Ryan is a senior consultant at Blue Granite. He has experience in business analytics and report development and has worked with all aspects of Power BI, including administration and monitoring since 2004. Ryan is also skilled in data analysis, data processing using R, Python, DAX, SQL, DBA, and M. Ryan has industry experience in healthcare and finance. That's a quick snippet of Ryan's bio. I'll let him tell you more of his story as he wishes. But at this time, I will turn the floor over to you, Ryan.
Okay, thanks. Can you hear me fine?
Yes, I hear you.
Okay, perfect. Okay, so let's get into this presentation. Okay, so as we just said, my name is Ryan Tankway. That's my nickname that was given to me during my football playing days. And I'm a senior consultant for Blue Granite. You see the some of the programming languages that I'm versed in. In addition to that, as I said, I'm a consultant for Blue Granite. Blue Granite, I knew about well before joining the team over a year ago. It's a well-respected Microsoft partner, and they also are a well-respected Databricks partner. It's an honor to be part of that team. I'm on the team with like-minded data geeks. A couple of my members are on the call right now. Dan, I believe Emily is on the call. It's a place where iron sharpens iron, and it's an honor to be on that team. In addition to being a consultant for Blue Granite, I'm a published author for a book that specializes in doing and using two of the most popular programming languages in data analytics, R and Python, and arguably the most popular data visualization tool, Power BI. So the book is a deep dive on that topic. And if you're interested in that, if you're a data scientist that interested in using Power BI, a data analyst, or someone who wants to take Power BI past what is capable of using the native features, I highly recommend this book. Now, one of the things I'm happy about this particular talk is that it can serve as proof to some of my friends that I actually have a job. For a long time, it'd be a situation where I'd be at the coffee shop work and I get a call from one of my boys from my hometown or one of my college teammates, and they say, Ryan, what you doing? I'm like, man, I'm at Starbucks working. And he's like, come on, man, you don't have a job, man. Come on, what you really doing? All you're doing is you're at Starbucks, sipping a latte, eating a blueberry scone, surfing the internet. You're not doing any work. So given that I have the blessing of Blue Granite to give this webinar, I can send a link to some of my friends to give them proof that I actually have a job. So I just put this slide in for some comedic relief. So the goal of this talk is to talk about modern data analytics. And before I start talking about modern data analytics, I want to give you a background of where data analytics started or how it started. Data analytics started back in the mid 1600s. That's when statistics were invented. So a lot of the measurements that we use in business today, you know, the mean, the mode, the median, standard deviations, a lot of those concepts have been around for quite some time. And even though we still are able to leverage those concepts and those techniques, they are not anything new. In addition to that, some of the most common algorithms that we use in machine learning, arguably the first one that you probably learned when you were in business school, linear regression, that dates back to the 1800s. So again, nothing new about a lot of the techniques that we use current day. In addition to that, second to the linear regression, probably the most commonly used machine learning algorithm is logistic regression. That dates back to the 1950s. So that has been around longer than most of the people on this call. Again, nothing new about that. Now, some of the newer techniques in data analytics from a data science standpoint or machine learning standpoint are algorithms like random forest. And you can think of a random forest as they're what they call ensemble models. And in layman's terms, what that means is that what you do is you take the results of many different models and you either take the average of those results or the most common occurrence of those results and use that as your answer. Now, this technique dates back to the early 2000s, and it's relatively new, ensemble modeling. And even though it's relatively new, we're talking about a couple decades. So again, a lot of the stuff that we use current day are techniques that are very valuable, but they've been around for some time. In addition to the techniques that we use, some of the tools that we use have been around for a while. The first computer dates back to the 1800s. Now, yeah, it looks a lot better than the current computer looks a lot better than what you see here, and the computers we have today are much more powerful, but the concept of the computer dates back many years. So some of the tools that we use in current data analytics have been around for some time. The relational database has been around since the late 1970s. Now, this guy that you see pictured here, Mr. Codd, the principles that he developed for relational database, the third number form, is still the gold standard today. So things that dates back to the late 1970s, a few years after I was born, are still very important today. So again, a lot of things about data analytics, nothing new. The spreadsheet dates back to that, around the same time period, the late 1970s. Here is a spreadsheet, VisiCalc, that was built for the Mac. You can see it looks like a lot like Excel. If you can take out the black screen in the background, you see that on the left, you have row numbers, and on the upper, up here, you have the column name. So the concept of a spreadsheet has been around for quite some time. And even though we try to get away from spreadsheets, we like to use fancier tools. But if you look at the most commonly used tool in data analytics right now, it is still Microsoft Excel. I don't care if you're talking about PhD level data scientists down to data analysts. They all, in some capacity, will use Microsoft Excel throughout their work. So here's another tool that has been around for quite some time. So you might be saying that, Ryan, if the concepts and the techniques that are used in data science has been around, or modern data analytics has been around for quite some time, and some of the tools, the computer, the databases and things of that nature have been around for quite some time, why do you need to come up with modern data analytics? What about data analytics had to be modernized in order to meet the needs of present day? Well, the first thing is the amount of data that we have present day. The amount of data that we are emitting in the present day is a lot more than what was generated back in the 1970s when the first relational database was thought up, or the first computer was thought up in the 1800s. We are producing massive amounts of data. So the traditional tools have a hard time working with the amount of data that we're producing nowadays. Another thing is that historically, when we worked with data, the data was already cleansed and it was already raw form in a tabular format in a relational database. Nowadays, we are working with unstructured data. A good example of unstructured data was given in a TED Talk early part of last year, I believe it was, when a brother talked about doing NLP. NLP stands for natural language processing. For I believe it was Pandora, and that technique, when you're doing natural language processing, sentiment analysis, topic analysis, when you're doing that type of analysis, you're doing it against unstructured data, and using traditional methods are not well equipped to handle that type of data. Another thing is, in the past, we really only dealt with data at rest. And when I say data at rest, data that's in a relational database is at rest. But now you're dealing with data in motion. Say you're the owner of you own a fleet of trucks and you want to collect telemetry data off of those trucks. That data is in motion. It's being streamed from the trucks to some data repository. You need a way to be able to interact with that data and analyze that data. And it's hard to do that using traditional tools from the past, but some of the modern tools make that type of analysis much easier. So with that being said, we are going to talk about how modern data analytics has addressed some of those issues that I talked about, that I just mentioned. And we're going to look at how modern data analytics has done that from 3 roles. And those 3 roles are the role of a data analyst, the data engineer, and the data scientist. And when we look at these 3 roles, we are going to describe tools that are available in a Microsoft data platform that can be leveraged, that will enable you to perform the tasks that each of those roles will perform. So we're going to start off with the data analyst, the modern data analyst. First, we're going to describe or mention some of the common names that you hear, or some of the common names that the modern data analyst is referred to. Those are data analyst, of course, or BI developer, report developer, or data visualization specialist. The BI developer, you can think of that person as the person that will take disparate data that's in an enterprise, model that data into what is known as a star schema format. And that's a format that is conducive for reporting, and they will make that data available to the enterprise for enterprise level reporting. And not only would they model the data, but they would be the ones that's responsible for calculating the different measures or metrics that the business will want, that incorporate certain types of business logic, whether it be a sales margin, whether it be a profit or EBITDA, wherever those metrics are, the developer will be responsible for coding those measures, and then they will make that available to the enterprise. In addition to doing that type of development, a BI developer will also do the dashboard development, they do the data visualization. They will pretty much cover the whole shebang when we're talking about the BI reporting, and BI stands for business intelligence. Now, the report developer, that is more of an arcane position. It's pretty much went away with a lot of these BI tools. But traditionally, what the report developer did in the past was they were the ones that were responsible for querying the enterprise data sources like the databases and what have you, and giving that information to the business in a tabular format. One of the enterprise tools that those people use on the Microsoft side will be SQL Server report services, or they just query the database directly. But for the most part, this position has morphed into the BI developer role. And the data visualization specialist, they are a subset of the BI developer. They are the people who they may not have the technical skills to be able to model the data like the BI developer will be able to do, but they will be able to take what the BI developer built and use that to build out nice dashboards and reports for the business. Some of the tools that the modern data analysts will use, one of them is Modern Excel. When I say Modern Excel, there are many features of Excel, Microsoft Excel, that many do not know about that are super powerful. One of those is Power Query. Let me back up a second. With Modern Excel, there is going to be another TED Talk that's going to be local to the Indiana chapter that I'm going to do that's going to focus on modern Excel. It's a lot of features in Microsoft Excel that has been newly added that it is worth your time to learn about. Now, this tool, Power Query, what it allows you to do is it allows you to do what they call self-service ETL. And ETL stands for extract, transform, load. In layman's terms, what that means is it allows you to take data from disparate sources, combine them, transform the data, and then load it into Microsoft Excel. Super powerful tool. In addition to that, you have Power Pivot. Power Pivot is the predecessor to Power BI, and it's built on the same type of technology. It uses what they call a tabular engine, the VertiPack engine, and what the VertiPack engine allows you to do is very efficiently process a lot of data. Now, I know in Excel, if you go all the way down to the bottom row, you'll see that you have available to you in Microsoft Excel a little bit more than 1 million records. And once you start having data sets in Microsoft Excel that's around the 200K point, you'll notice that you will have a lot of performance issues. Or if you have a bunch of spreadsheets in Excel with multiple data sets and you're trying to connect those spreadsheets using traditional methods like the VLOOKUP, after a while you will run into a lot of performance issues. Well, Power Pivot allows you to get over that. And then there are some new functions available in Excel. One is the let function that's super powerful, let, L-E-T, and then they have Lambda functions. Some of you that are, Python programmers, you are familiar with Lambda functions. Those are available in Microsoft Excel right now. Super powerful feature. In addition to that, yeah, SQL Server. SQL Server is also a powerful tool for the data analyst. That's in the enterprise, typically most of your data will come from an enterprise database like SQL Server. And starting in 2016, for some of you all that are programmers in R and Python, in 2016, R was added to SQL Server, and then starting in SQL Server version 2017, Python was added to the mix. So now you can do R and Python programming inside a database. And some of you all that are Java programmers, Java was added to SQL Server in 2019. Azure SQL DB, that is another SQL database, but instead of being on-prem, it's in the cloud. And with it being in the cloud, it's more accessible to your applications that uses the data source. So that is another big feature that has been added to the Microsoft Data Platform. Having your database in the cloud makes it much easier to build applications at scale. And then also makes it much easier for your data analysts to do their work. Power BI, we already talked about Power BI. This is arguably the best tool out there and most popular tool when it comes to data viz. I know we probably have some Tableau users in here that disagree with that assessment, but it's an extremely powerful tool for data analysis, and it allows the data analysts to share their findings with other people in the organization. Some of the common programming languages that a data analyst will use, the most important would be T-SQL, because you got to interact with the database. You got to know how to communicate with the database to get information out of the enterprise system into your repository so you can do your analysis. Now, if you're in a Microsoft stack, the programming language DAX. That stands for Data Analytics Expressions. That's a programming language that is specific to Power BI. Very powerful programming language. You'll be amazed at the type of business logic that you can incorporate into your solutions using that programming language. M is another language that's specific to Power BI in the Microsoft ecosystem, and that is a programming language that is used for data wrangling. For the most part, you will really have to use M code because the interfaces that uses M, they do a great job of allowing you to do most of what you need to do through an interface. But when you need to go down and write code to do certain transformations, knowing M will help you out. And you would notice that for the data analyst, I mentioned R before Python. And I think for the business standpoint, I think that the R programming language is a better programming language for business users because R is a language that is domain specific. It is a language written by data analysts for data analysts. Camilla here, she will correct me and say it's written by statisticians for statisticians. And with it being written in by statisticians for statisticians or analysts for analysis, with it being domain specific, there will be many different packages that will be available in R that will do whatever type of job you need to do. I was talking to a friend a few months ago that does research for the University of Michigan, and she was doing some longitudinal data analysis. And I told her, I said, you should check out R because R, I'm pretty sure, has a package that does exactly what you need to do. And she was giving me pushback. And I went to my boy Google and I asked Google, show me some information about doing longitudinal data analysis in R. And a bunch of packages popped up and a book popped up, that does that. Now, Python, having that same type of support from a data analysis standpoint would not be the same. So the next role we want to talk about is a data engineer. And this is probably the most, the role that does the most work because in data science or data analytics, many would say that up to 80% of the work is getting your data in order. So with that being said, you will have your data engineers that will take disparate data that is used by enterprise and model that data for the BI developer that I mentioned before. And with the data engineers, just like with the data analysts, there are different roles or different names that you will see them being referred to. One of those is a data engineer, of course. A more traditional role name for the data engineer would be ETL developer, with ETL standing for extract, transform, and load, meaning that you're taking data from a source, transforming that data and loading it into a destination. And then another term that is often used to refer to people in this role will be a data wrangler or data manager. In the Microsoft stack, there are some tools that are very popular to a person in this role. One of those is Azure Data Factory. Azure Data Factory is a tool that does a lot of what was done on-prem with SSIS, but it's much better in many ways because it's more customizable. Unlike SQL Server integration services, SSIS, or some other on-prem ETL tools like Talent or what's another one, Informatica. One of the big differences with this particular tool is that it is code first. And with it being code first, you can customize a lot of things a lot easier. And then also with it being hosted in the cloud, it's much more scalable than what a tool like SSIS would be. So that's another good thing. And then a nice thing about it, it's all underneath the hood is JSON based. So that lends itself well to DevOps. In addition to that, you have Databricks. And as I told you earlier, the firm I work for, they are a partner with Databricks. Now, Databricks is an awesome tool. This tool right here allows you to process massive amounts of data. I'm talking about petabytes scale when I mentioned about the amount of data that this particular tool can process. Underneath the hood is based off of open source software called Spark. With this tool, it's pretty approachable to data scientists or ETL developers because you have an option to program in this particular tool using multiple different languages. Those languages include Scala, but some of the more common languages are Python, which a lot of data scientists and data engineers are well versed in, R, which is a language that many data scientists are well versed in, and then SQL, which all three are versed in. When I say all three, I'm referring to the analyst and the data engineer as well as the data scientist. Super powerful tool. In addition to allow you to process massive amount of data, it also allows you to apply machine learning algorithms or your data science models to this, to massive amounts of data at scale. Then there's another tool that is unique to Azure, and this tool is called Synapse. Now, Synapse is a tool that is meant to do everything. So inside this tool, you have features. You have Azure Data Factory-like features in there that allows you to move data around. You have you have Spark in there that allows you to do some of the functionality that you have in Azure Databricks. And then you have a relational database component in there as well. Super powerful tool. It's the tool that's meant for enterprise data warehouse type of solution. In addition to that, one of the things that set this apart amongst the things that I just mentioned is that the world's most popular data visualization tool is baked inside of this, and that tool is Power BI. So you can easily sit Power BI on top of Azure Synapse and visualize the data that you have in there. And then for some of you all, I know that in the call that we had recently, a few months ago, I remember one of the attendees were talking about Snowflake. One of the things that's good about Microsoft now that it's different about Microsoft in days of old is that Microsoft embraced not only the open source community but also other people. Other providers. Databricks is not a Microsoft tool. Neither is this tool right here, Snowflake. If you are a person that uses Snowflake, or organization that uses Snowflake, you can do that in the Microsoft ecosystem using Azure. Some of the common tools that, the common programmers that languages that you use as a data engineer are SQL, Python, and PowerShell. From a programming language standpoint, there's no real need for a data engineer to learn R. But Python is a first-class citizen, and Databricks is pretty much second to Scala from a Databricks standpoint, and it's one of the most popular programming languages from a data engineering standpoint. Again, T-SQL trumps all the languages. I remember a while ago they was talking about a move away from T-SQL. That only happened for a couple of years, and people, got to their senses and realized SQL is going nowhere. Super powerful programming language to learn. And then you see I have PowerShell in there. PowerShell is a scripting language specific to Microsoft, and this thing is powerful. I am a newbie to PowerShell, but if you're doing anything of significance in the Microsoft data platform, I highly recommend you learn this language. It can enable you to automate many of the mundane tasks that you have in a very efficient way. And then if you learn PowerShell, there's a tool in Azure called Azure Automation that will allow you to do a lot of great things within the Azure environment in an automated fashion. Now, last but not least, we're going to talk about the data scientists. Data scientists can be referred to these, this is a personal opinion that I'm giving you right now. Defining data scientists is like the hardest thing to do. When I first started in my career, if you had a PhD, that automatically made you a data scientist. But then now you have all sorts of people call them data scientists. Some are qualified. You have people like me that have the imposter syndrome, so I would not dare call myself one. But me personally, I would call a data scientist, or I think a lot of statisticians based off of their training, I will consider them a data scientist, an artificial intelligence engineer, and an actuary. I actually think that the actuaries are some of the first data science. If you know anything about the actuarial exams, that speaks data science. I mean, you got a business component which encompasses the domain expertise. You got a technical component, and you have a math component, to that as well, quantitative component. One of the tests is mathematical statistics. So with that being said, I think that those men and women are some of the first data scientists. Now, some of the tools that are available to you from in the Microsoft ecosystem, one of them that I love a lot, and I shared it with one of the people on the call, Camille, Azure Machine Learning Services. This thing is super powerful, and I think that it is going to get a lot of shine in the future. One of the things I like about Azure Machine Learning is that it allows you to productionize your machine learning models. In the past, you had a situation where, say we had Camille, she developed this awesome machine learning model. And she's, and I'm the data engineer on the team. She said, Brian, I have this machine learning model. You need to put it into production. In the past, it was a real bit to do the way I had to take the model that she built in R, Python, refactor it into Java or some other language. And about the time I put that model into production, it is probably stale at that point. Well, with Azure Machine Learning, it addresses that, and it makes it much easier to productionize your model. Not only does it make it easier to productionize your model, but it does so in a DevOps type of fashion. There is a concept called ML Ops, which is machine learning ops, which is DevOps for machine learning. So it allows you to version control your machine learning models and your data sets and what have you. This is an awesome tool. Now to the business, what this type of tool allow you to do is, if you develop a machine learning model, it will not only allow you to make the process of developing that model much easier, but in addition to that, it will make it such that where you can expose that model so that you can use it for other applications. It will allow that process to be much easier as well. Another tool that I use a lot is this data science virtual machine. As a data scientist or a person who's doing data science, you need a lot of different software and different tools configuring your machine in order to be able to do it correctly. And creating that environment yourself can be a nightmare. With a data science virtual machine, you just tell Azure what you want your configuration to be, and then in minutes, you will have a machine built with all these awesome tools that are important to data science configured within minutes. And then also for the data scientists, you'll see that some of the tools that were used by the data engineers also used by the data scientists, but in a different capacity. Like with Azure Synapse, the data scientist will give his or her model to the data engineer so that they can use it within that environment. With the SQL Server, I mentioned earlier about a feature in SQL Server that started in SQL Server 2016 called SQL Server Machine Learning Services. That allowed data scientists to do data science inside the database. As your former president said, that is bigly. That is bigly because you have a situation where if you have an on-prem database, you're able to do data science where the data is. You don't have to worry about taking that data out of the database, put it into some another area, do your data science, and then put your data back into that database. All that data movement that I just described is a security threat. Well, if you can keep all your data inside a database and use R, use Python inside a database to do your data science, that can be pretty big for on-prem databases. In addition to that, there are big data tools for R and Python that's built into SQL Server. On the R side, it's called RevelScale R. On the Python side, it's called RevelScale Pi, that allow you to use Python and R on massive amounts of data. And then we already mentioned Databricks, and from a data scientist standpoint, there are algorithms that you can use that are built into Azure Databricks that allow you to build machine learning models. And then again, Azure SQL database, that's a nice data store where you can put a lot of enterprise data and have it easily accessible to your data scientists. Power BI is another tool that in the Microsoft ecosystem that is very important to the data scientists. Power BI have the traditional tools that we are well aware of from a data viz standpoint, but as I pointed out earlier in my book, it also has the ability to use R and Python within Power BI. That can be extremely powerful to a data scientist. In addition to that, you have a feature in Power BI called AutoML. AutoML stands for automated machine learning. It allows the data scientists to rapidly build models for the business very efficiently. And then in addition to that, you have Modern Excel. And I showed you earlier about some of the features in Modern Excel that are super powerful. And just like with the data analyst, Excel is not going away from the toolkit of the data scientists. It's going to be there to stay. In addition, and then the last thing I want to point out about the data scientists are the programming languages that you use. T-SQL, again, is super important. The reason why it's important, not because you're going to use T-SQL to build these fancy algorithms, but the data scientists need to get the data that they need to work on. And in order to get the data from the database, they need to have a good understanding of T-SQL in order to extract the information out. Then next to that, you have R and Python. R depends on, eventually a data scientist will have to be a polyglot and learn both of them. But the start is, depends on, their background. If they're coming from stats, their background, if they're coming from stats, their first language may be R, and then eventually they will learn Python. If they're coming from a computer science background, then their first data science language will be Python, and then eventually they'll learn R. Both of those languages are powerful languages, and they're good in their own right. And again, if you're going to do anything of significance in Power BI, you're going to have to learn a little bit of DAX and M in order to be able to be effective in those tools. That's the end of this presentation, and this is the first of three talks. The next talk will be by my colleague Emily. Emily will do a talk on best practices in data viz, and then that would be followed by a talk that will be co-presented by Megan and Tom, and they'll talk about the day in the life of a data scientist / data engineer. They'll tell you about the type of tasks that they are responsible for, some of the things that they need to know in order to be able to do their job effectively. They will give you a more in-depth view of what it looks like to have those roles. And the last thing I want to give a shout out to my teammate, he's here, Dan. Dan has been he's been very instrumental in putting all this together. He has been communicating with BDPA to make sure we had the dates available and all. So Dan, I appreciate you for your help. So that's it. So with that being said, are there any questions that the attendees have?
Okay, at this time, I'm going to allow you all to unmute yourself. So you have the ability to unmute now. I just ask that you stay on mute if you're not speaking. We do have 2 questions in the chat, so I'll give you all precedence. I think Stanley had the first question. So if you're out there, Stan, and want to ask your question, please go ahead at this time.
Hey, Dan, thank you so much for this. Ryan, thanks for this great presentation. So my question is around predictive analytics. Could you talk a little bit about the building blocks that goes into a successful predictive analytics capability for an organization?
Okay, so when you say capabilities, are you talking about from a solution standpoint, or are you talking about from a skilling standpoint of the people that's building out the predictive analytics?
From a solution standpoint.
Okay, from a solution standpoint, you need to have the right team. So like, at Blue Granite, we have the right team. We have a team of what I mentioned before, the data engineers. Those will be the people on your team that will be able to get the data that's needed for your solution available so that you can actually do the predictive analytics. In addition to that, you would need somebody from your organization that have very good domain expertise. Because a lot of times when you're doing that type of analysis, you may have somebody that may have the technical skills, they may even have the knowledge about the different algorithms that you can use in data science, but they don't have the domain expertise. So if your data scientists do not have that domain expertise that's working on a project, I will highly recommend that you have somebody in the business that has the domain expertise that will partner up with the data scientist so that he or she can help the data scientist come up with a solution. In addition to that, you'll need a data scientist, with the math aptitude and understanding of the algorithms, to build out the model. And last but not least, you'll need a champion. When I say a champion, you need a champion of the project, because a lot of times things will not go as smoothly as anticipated. With data science, it's an iterative process. Data science is essentially using a scientific method on data analysis. So you would start off with identifying the business problem, and then you try to collect data to solve that business problem, and then the data scientist will build a model to try to predict or come up with a prediction to that meets the needs of the business. Oftentimes that takes many iterations to do. And so you would need a good champion of the project that not only understands the complexity of data science, but also is a believer of the project, so that when you're met with those tough challenges, they will allow you to stick it through. So I think those are the components that you need. You need to have a solid data engineering team. You need to have a solid data scientist. You need to have somebody on the team with excellent domain expertise, and you also need to have a competent data scientist. Did I say that twice? If I did, forgive me.
I have a question for you, Ryan. As it relates to, for people who are trying to get into this space.
This is my boy. Yeah, this is okay. Yeah, I recognize the voice, man.
Yeah, man. So I'm in this space, and I've expressed some of that to Ryan. And what I've come to find as somebody who's in this space, I've had to go get a master's degree. I'm working on a doctorate degree, and I'm doing way more than I should have to do to enter into this space. So my question, not just as much as to you, Ryan, but also to BDPA, is have you all thought about creating environments where people who are interested in this space can gain experience so that they can enter into the field?
Yeah, and that's, man, and as I told you, and then if anybody want to chime in from Blue Granite, or anybody that's in this chat want to chime in, feel free to do so. But the path where I'm at right now hasn't been easy at all for me. It's been super hard for me to get the relative success, which is I think is nominal, that I had to date. It has meant a lot of times when my boys are partying or doing whatever, I'm studying R and Python, trying to get in this space, where at my current job, I'm not allowed to do the things I want to do. So sometimes you got to be very creative in creating those opportunities. Some of the things that I've done is it's hard to do that now, but there were some talks. There was an organization called, and it's defunct now, but it was called SQL Saturday, where they had different talks throughout the country on all things SQL Server related. And I presented at many of those conferences for multiple reasons. One, to share a little bit of what I knew with the community, but also as a way to force myself to learn things that I wasn't able to learn in my day job. So that's one method. Another method is to do the things that you're doing now. And then you and I and some other people, we network outside. I think that it's very important to build up that network of like-minded people, so that you can build your skill set up. But I don't think there's a clear answer to that question. It's going to be I know it was a tough role for me, and it's still a tough role. I don't know an easy answer to that, man.
And I do want to address the BDPA specific portion of that. We do have Camille Little on the line, and she is actually leading up our efforts to start a data science academy this year, which is focused specifically on data science and people in that field. Camille, I don't know if you want to chime in a little bit on that, but she did share on that a little 2 weeks ago in our tech talk. Camille, you want to chime in briefly?
Yeah, sure. Yeah, so again, I'm Camille Little. I am a first year PhD student in electrical engineering, but basically AI and data science at Rice University. And yeah, I totally understand the challenges. I basically left undergrad thinking that I wanted to go into data science, but as I was a statistician trained, so I was a statistics major undergrad, but I didn't feel like I really had the necessary skills. And so I kind of just went for it and went for the PhD. But yeah, so basically with the Data Science Academy, it's more so focused with college students and trying to just improve the pipeline within BDPA to get more students in data science. And so that will hopefully consist of a series of very technical workshops. So for, Ryan mentioned in his talk, the power of Excel. I actually didn't even know about like using Lambda functions in Excel. I'm over here like texting my dad, like, you can do that? Like, I had no idea. And so basically, yeah, maybe Excel for data science, Python for data science, R for data science. So a series of workshops, and then hopefully leading to a competition in August that's that would be held at the national conference. That's sort of similar to what we see with the high school app development competition. So we are working really hard to try to improve that pipeline and just make it a bit smoother for students who are trying to enter this field.
Yeah, and I'm still on board to help you out with that, right, Camille?
Yeah. I was gonna send you a text, but I was like, let me wait till after this little talk or whatever. But yeah, we'll be connecting probably later today.
I'm glad you do, because I would have stopped my presentation and said, let me see, I got a test with someone.
Oh my gosh.
Thanks, Camille. We do have another question in the chat from Oscar. Oscar, do you want to ask your question? Let's see if Oscar is still in. It looks like Oscar is on.
Yes, I was just interested in how one can apply other programming languages to this type of practices related to data science, such as JavaScript, which is the most used language on the web and for web development.
Mm-hmm. I think every language has its purpose, and I think certain languages are better equipped to do certain things than others. And from a data science standpoint, I wouldn't focus on using Java per se to do data science. If I was interested in getting into data science, I would focus on more of the data science specific programming languages like R and Python. And then there's other languages that are not as popular, but are getting a lot of raves in the data science community. One of those programming languages is Julia. It's supposed to be like, the best of both worlds between R and Python. It's supposed to be, what they call that, like readable like Python, but have a lot of the domain specific tools like R has, and it's supposed to be, close to the speed of C. So with that being said, I will focus on being a person that will be a polyglot, use the right tool for the job, and not forcing the tool to do something that it's not meant to do. Like for instance, I've seen people on the SQL Server side do things with SQL that was not meant for SQL, but would have been extremely efficient if you chose to use R or Python. So with that being said, I think it would be wise to learn all the tools is out there and get a good high level understanding of those tools and know when to use, know how to identify which tool you should use for the given task. And I wouldn't use JavaScript for data science. Would you agree with that, Camille?
Absolutely. Mm-hmm.
Looks like Marcus Rodriguez has a question. Marcus, would you like to ask your question?
Yes. Hi. Hi, Ryan. And this is a great talk. One of the best analytics talks I've ever been around. So I'm a data professional and I work in pharmaceutical industry. Mm-hmm. And we have to do kind of like some predictive analytics, kind of like every month, and kind of take random data. But now I kind of have a better understanding of the job, and I kind of want to just automate that process so I don't have to see it every month, where I want to run a large predictive analytics over a large data set, but it's micro analytics across probably 200, 250,000 rows.
Mhm.
And I have experience with R. I don't like using R, but I've never used Python. So I was wondering if that was something that Python can do, just kind of running a predictive analytics over a large scale and kind of outputting it on a regular basis.
You can actually do it with R as well. And I mean, it depends. Like, you know, when you say pharmaceutical, are you with Lilly? Or you?
No.
Okay. Okay. Because that's what I was about to say. I know a person who developed a package that works with Lilly called Drake. It's a very popular package. But with that being said, in today's world, there's a lot of attention around Python when it comes to productionizing your data science models, but R is available in a lot of your enterprise tools as well. So depending on your problem, you make the tool that I mentioned before, Azure Machine Learning Services, both R and Python are first class programming languages in that particular tool, and that tool allows you to productionize your data science. So I think that it had to have a bigger question. I need to look at that situation better. But if you're using on a high level, my answer would be if you're using Azure Machine Learning Services, you probably can get that done with just either one of those languages. And then in the future, you will want to get to the point, if you know R, you would want to learn Python, because there's packages in both Python and R where, you can go back and forth between both languages. So if you learn both languages, you can be the best of both worlds. I mean, in R, in Python and Anaconda, R is part of that distribution. Then on the R side, there was just a webinar that I hate that I wasn't able to attend, that was talking about the integration of Python in R Studio. So, I don't think there's a situation where you got to pick one or the other, but I do think that, start off with a simple project. In many cases, you can be okay with either languages because of the tools that's available on a production scale. Like I mentioned earlier, R being inside of SQL Server, that allows you to productionize models and work at data at scale. Or R and Databricks. The tool I mentioned earlier about the tool that allows you to work with massive amount of data. In Databricks, you have the option to use R and Python. And then also you have in Databricks, Sparkly R. I think I'm pronouncing it correctly, but if you're familiar with dplyr on the R side, then you know Sparkly R, because it's pretty much the same syntax. And on the Python side, if you are familiar with pandas, there's a package in Databricks called Colas that will allow you to do that same type of data wrangling that you can do using pandas on your local machine in Databricks, but it allows you to do it at scale. And the last I checked this summer, they said that Colas was like 90% at parity with pandas. So make a long story short, the tooling that's available to you now, you can do a lot of things at scale that traditionally you were not able to.
Yeah, thank you. I'm only going to ask because I've used R before and it's not object oriented, so I've kind of struggled with that non-object oriented kind of language, and I do better.
Yeah, well, Python. Yeah, so have a talk with me. Reach out to me on LinkedIn and give me a better, some more information about what you're saying, and then I can give you a better answer about that.
Okay, thank you.
No problem.
Okay, thank you all. We are at time, and I want to be respectful of your time. As Ryan said, please connect with him on LinkedIn, and he will definitely be glad to connect with anyone to continue these conversations. Like, I still see a few questions coming through the chat, so I want you to be able to continue those conversations. We will, as Ryan spoke to, this is the first of a 3-part series from Blue Granite in our data and analytics series to close out our Q1 theme. So we do look forward to having you back on March 12th. We will have Emily speaking on data visualization principles and best practices. And then March 26th, we will have Megan and Tom speaking from a day in the life of a data scientist and data engineer. So we look forward to having you back. Dan shared a link for those looking for potential opportunities with Blue Granite earlier in the chat. Dan, I'll give you a quick second if you want to give some remarks to close us out.
And Dan, also, can you share with them the events page? I thought I had it on here that shows some of the training that we offer at Blue Granite for free.
Maybe you could look at it real quick. I don't have it at my
Okay.
fingertips, but so just real quick, again, I appreciate that we're at time. So thanks for the time. Definitely the 2 sessions coming up. Emily is going to do that data visualization, but from a different angle. I think that you may be thinking more visualization as an art form and delivering information with your visuals, not just the kind of turning a wrench kind of stuff. And I think already I've gotten some feedback from the questions that I'm going to push into the have that third presentation cover. So that's awesome. Listen, part of why we're here, we're obviously introducing our company. We're introducing that we're hiring and that we're looking for people that are interested in this field, but we're also pitching this field. Microsoft data analytics, that whole space is just absolutely exploding, and Databricks. And we love it. We're interested in it. And so we want to share that. People helped us coming up. We want to turn around and help others. Reach out to us, even if you're not interested in Blue Granite, even if you're going to go somewhere else or stay where you are. We're just geeks about this whole stuff. So we love to talk about it and we want to share what we know. So great presentation, Ryan. And thanks for the moment to chat.
And the last thing, there are some people on here that I think I haven't looked through their names yet, but I've been trying for the last few months do a follow-up on a Python workshop that I did at BDPA this past summer, and it's been hard, getting everybody under one accord. I've been having issues with, my time schedule, with my schedule, and also other people, so it's been hard getting a date. So if those people that want to be part of that Python workshop that will show you how you can use Python to get demographic information from the US Census, if you all want to stay after this call so that we can, finalize the date, please do that.
Okay, thank you for that, Ryan. The recording of this session will be on our web page. I just dropped that link in the chat as well. That's essentially BDPA. Looks like it's changed up a little bit now. If you go to bdpa.org, go to the Tech and Career Talks tab, you'll find our page. But there's the direct link in the chat. So feel free to check that out, to check out our previous talks as well as this one if you want to go back and revisit it. Thank you all again for joining. Stay safe. Stay warm if you're in the Midwest. Enjoy the warmth if you're not. And we look forward to having you back in the next talk. Sounds like Ryan was going to give an opportunity to connect with a few people afterwards in regards to a Python training. So I'll leave the call open for those who do wish to have that conversation, but I will stop the recording now. So thank you. Enjoy your weekend.
Thank you all.